Hi again.
Good to see you all. Today I will be presenting to you my 10 weeks effort of building my project called R trees, which is an R package written to generate phylogenetic trees for ecologists. So what is R trees? R trees is an R package written to derive genetic ancestral trees of any given species. The ultimate goal of this package is to remove the barriers of deriving such phylogenies without any prior knowledge of programming from the user. Commonly, there are many similar softwares that generate lines of code, which then the user would run on their local machine in R studios. Now, the problem occurs when a student or staff with no programming runs into syntax errors in between the copying and pasting process. In order to eliminate this hassle altogether, under the guidance of Dr. Dejang Lee, we produced R trees, which reduces the user's efforts tremendously. With the help of R Shiny and its user-friendly interface, we were able to build and maintain R trees' integral functions, as well as preserve its ability to be used by the novice user. So exactly, how did we achieve this? The Shiny application consists of two key components: the server that runs your R code, and a user interface that runs through the user's web browser or local machine. The UI will contain a layout which can place input fields and outputs, such as visualizations. Input fields are things like text boxes, drop-down menus, calendar control, that send their values back to the R server. The R server then updates calculations and those visualizations, which get sent back to the UI to be displayed to the user. It's important to note that the Shiny application always needs a user running R to work. Now it's time for a small demonstration of this. So firstly, we would prompt the user to select one of these taxons as the first parameter, whether the species of interest is a plant, fish, bird, mammal, or other. Then we would have them insert the names of the species for which they would like a phylogeny, which would then be separated by commas, or they can always simply upload a CSV file of the species with the respective family and genus columns populated. Lastly, we would ask them to either go with the predefined tree, which is already offered with every single taxon, or if they would like to use a custom one, they can always go ahead and do that as well. For the sake of conserving time, I have a screenshot of the input query as well as the output result. We were interested in looking at the phylogeny of a plant species, and then we inputted the names of the species of plants, and then chose the standard predefined tree, and then hit build. The output on the right side, we see 5 names of the species that we originally inputted, organized as a cladogram. We also added a function to observe the tree in the form of text instruction, aka code. Here we see a much larger tree with hundreds of species of plants, which is of course generated reading a CSV file. A file such size would typically take up to 1.5 minutes to finish building. So challenges and learning outcomes. At first, I found my summer project very confusing since I had not taken biology in over 5 years, let alone ecology. This project was borderline completely out of my programming comfort zone. Looking back, I realized it was an opportunity to learn and grow my present skill sets, not simply learning to write new lines of code in a different language, but rather the principle of learning how to work in a collaborative setting and taking instructions in order to reach the weekly goals. While beginning to learn Shiny, I found it very obsolete to read books and watch mundane tutorials. And then I was later advised by my mentor to begin applying my new learnings from those books and tutorials and enforce myself into applying it into actual code. Even just writing pseudocode and running into problems as you go and then finding solutions to those problems is where I did most of my learning. If it wasn't for that, I would most likely still have been stuck learning how to write Hello World in week 4 or 5. This is really where I had the chance to apply deductive reasoning and essentially learn as you go instead of learning entirely from the ground up. This lesson may sound trivial, but I think this would certainly have its carryover value into my future endeavors. Lastly, in the case of Shiny, I particularly enjoyed working with its intricacies and vast variety of its applications. I believe it's a very useful tool to deliver a realistic function, or rather a visual application of your work. Shiny allows our users to gain great data insights and render actionable data to the user. It allows all the advanced analytics of R to be made available to the developer. For me, R helped me learn how to communicate results via interactive trees and actual meaningful visuals. So this is all I have for you today. Thank you so much for listening. Questions and comments are welcome. You may address them to the email provided here. And thank you.
Okay.
Thank you very much.
Any questions?
Any question or comment?
I guess my comment will be it's a very interesting project, and I'm glad you guys were able to put it together. It's really interesting.
Thank you.
You
I
are
have a
going to
question.
yes, please.
How did you go about learning R?
Learning R, like you asking me or asking my mentee?
You.
Me, it's like, I think that's mostly during my graduate school, and I need to do, my dissertation, so that, and back to then, you have tons of time. You just learn by, by doing it, just Google around. I think I probably took one short R course, but that's it. Then the other thing is just you need to dive in, and if you need to do anything, and then try to find out how to do that with the specific tool you want to learn. I think that's the best way I find to learn anything. Like reading books, that's helpful, but it's not really that efficient of using your time to learn new things. That's what I learned.
Any other question or comment? Okay. So if there are no more questions, then we can go with the next speaker, Yemia